And we're on part 5, solving equations with several steps. Again, step 1, it says, remove brackets with the distributive property. We can rephrase that step to it's basically do any math that you know how to do. In other words, if you have like terms on a side, you combine them. If you have a number outside of brackets, you know that you can distribute. We had some of this in our test, and you had some of this on the review questions. So we've done some of this already, but this is just formally reviewing it. Okay, this is the important thing. Whenever you have like terms, you're going to want to combine them. Sometimes they're on other sides of the equation, so that's where you have to move one from one side of the equation to the other by doing the opposite ideas. In the end, our goal is to get the variable by itself. And we do that by having all the terms with the variable on one side, all the terms with numbers on the other side. So what does it look like? Okay, I'm solving this equation. 2 bracket x plus 1 equals 4. We've seen on the left-hand side, we saw this in our polynomials unit. When you have a number outside of brackets, you can distribute. What does distribute look like? Multiply the 2 by the x, multiply the 2 by the 1. What would you get? 2 times x is 2x, 2 times 1 is plus 2, and it's equal to 4. Now, do we have any like terms? Yes. The 2 and the 4 are like terms. We need to have them on the same side. I'm going to subtract 2 because I would like to move this 2 to that side, so I have my x's on one side, my numbers on the other side. What will that give me? Well, now, on the left-hand side, I just have 2x left because 2 minus 2 is 0, and 4 minus 2 is 2. I want to get x by itself. Right now it's multiplied by 2. The opposite of multiplying by 2 is to divide by 2. If I do that, I get x all by itself, and x is equal to 1. So same thing in example 2. We see this 3 outside the brackets. We can distribute. 3 times p, 3p, 3 times 2, plus 6 equals -9. Do we have like terms? Yes. I'm going to move this 6 to this side by subtracting 6 on both sides. That would leave me with just 3p on the left-hand side, and -9 minus 6 is equal to -15. Question?
Number E and number C are the same thing.
Sometimes that happens. And then opposite of multiplying is dividing. And so dividing both sides by 3, -15 divided by 3 would give us -5. And finally, the last one. Again, we have a number out inside of brackets. We can distribute that. That would give us -4 equals 2p plus 10. The 10 and the 4 are like terms. I'm going to move the 10 to this side by subtracting 10 on both sides. Sometimes, Nevaeh, if you're in your check, if it's coming up wrong in your check, then, and you can't see your mistake, it's better to start it again on scrap paper without looking at what you did. Because looking at what you did, you'll make the same mistake again. Starting it again will give you a chance. Don't look at your work, because then you'll be tempted to do the same mistake. Divide both sides by 2. That would get p by itself. Now you can leave the p on this side, or Some people, when they solve, they always like to put the variable first. Either of these would be fine. You get p is equal to -7. Okay, 3 to try on your own. I will put up the answers in a minute, but I'll keep these ones up so you can see them. Okay, let's check how we did here. Okay. If I distribute, I get 3x plus 3 equals 6. These are like terms, so I'm going to subtract 3 on both sides. That will give me 3x equals 3. Now I can divide by both sides by 3. And I get x equals 1. Now for this first example, I walked around and Griffin said, I do it a little bit different. Is this wrong? So it wasn't. Okay? When you see math that you can do that math. So for example, what we did first is we saw that we can distribute, and that's allowed. Okay? But Griffin saw that, hey, this is 3 times this. What's the opposite of multiplying by 3? Dividing by 3. So he divided this whole side by 3 and this whole side by 3. Now, the reason I don't do this as the primary method is because sometimes you have more than just the distribution. And when you divide a side, you have to divide the whole side by 3. But in this case, it works out perfectly because 3 divided by 3, that's 1. And you would get x plus 1 equals 2. Then to combine my like terms, I'd have to subtract 1 on both sides. And you get x equals 1 as well. So both of those methods work as long as what you do to one side, you do to the other side, and you ask yourself, if I divide this whole side by 3, can I cancel that out? Yes, I can. Okay? I'm going to stick to the distributing because I find that as you get into more complicated questions, that'll cause less mistakes.
No, it's because I was checking them and then they were all wrong, and I was like, No, it actually helped.
And for the last one, all right, how did you do on those 3?
Wait, we're on this part?
Okay, so now example 2, we have distribution on both sides. So here I can distribute the 2, and here I can distribute the 4. Would give me 2x minus 2 and 4x plus 4. Now I have like terms. Can you see that the 4x and the 2x are like terms? In this case, I would probably move it to this side so I don't get any negatives with my x. But that means with these like terms, my 4 and my 2, if you're moving your x's to the right-hand side of your equation, you'll want to move your numbers to the other side. So I'm going to subtract 4 for both of those. What will that give me? On my left side, I'll have my numbers. So it'll be minus 2 minus 4 will give me minus 6. On my right side, I'm going to have 4x minus 2x is 2x. And now what's the opposite of multiplying by 2? Divide both sides by 2. and you will get x is equal to minus 3. So initially, if you look at it, there's a lot of complicated looking stuff going on, but in reality, you're just combining like terms. If you can keep track of what you're moving from one side to the other, and this is where it's nice, like I color-coded it, I showed arrows to remind myself where I was going. That can help you a lot. So if we look at the next one. There's a mistake on the next one. The P, I'm sorry, should have been an X, so you can put a big X over the P. Makes more sense, doesn't it? Otherwise, it's impossible to solve. So again, we're distributing. I will get 3x minus 6. And on this side, negative 3 times x would be negative 3x, negative 3 times 4, negative 12. I have like terms. So in this case, it's not going to be 0x, because I'm going to move it to the positive side, which means I need to add 3x and add 3x. And for these like terms, that means I'm going to move them to the right side. So I need to add 6 and add 6. What does that give me? 6x for my x's. And my numbers are going to be on this side. They'll be negative 6. Divide both sides by 6. Negative 1. But it is true, if that stayed a p, there would be no way to solve it. Because if you have one equation with two things that you do not know, then there are multiple answers. In fact, where have we seen one equation with two things? Those were our formulas in linear relations. Remember when you were like, number of squares equals figure number times 2 plus 2. And that creates a formula. If you have two things, it creates a formula, and the formula has multiple answers, because there's an answer for figure 1. There's an answer for figure 2. There's an answer for figure 3. And it made a graph and a whole line. So when you have two variables in one equation, you actually get multiple answers, and those multiple answers that we saw in our previous unit, they actually form a line or a different kind of graph. In grade 10, you will find out that if you have one equation that makes one line and another equation with those same two variables that makes another line, there's going to be one point where those two lines cross, and that'll be the only answer that solves both of those equations. But that's next year. And once again, I would distribute. So we would get 10w minus 5 equals 9w minus 6. Do I have like terms? Absolutely. So I look at my w's first. In this case, I would move them to this side so they stay positive. Minus 9w minus 9w. These are like terms. And in this case, since I move my variables to the left side, I'm going to move my numbers to the right side. I have to add 5 and add 5. Really nice in this one is 10w minus 9w is just w. And so all of a sudden we're done the whole thing, just like that. So there are 3 for you to try. See how you did on the 3. Question number 1. Did you distribute and get 3x minus 3 and 6x plus 6? Then these are like terms. In this case, I'd move it to this side. Minus 3x minus 3x. These are like terms, and I have to move the numbers to this side. So minus 6 and minus 6. What does that give me? minus 9 equals 3x. Divide both sides by 3. And x is equal to minus 3 for the first one.
Oh yeah, yeah, yeah. I thought I was just confused with like,
All right, second example.
'cause I did it the wrong.
Distribute the 2. 2p. I know, you know why that's sad, eh? That's the first song that came into my head when I wrote 2p as well. I know. It's going to last, right?
I love
Okay, this one will go this way. Add 2p, add 2p. These are like terms going to this side, add 6, add 6. What do we get? We get 4p equals negative 10. Divide. I love the backyardigans. Now here, we get p is equal to negative 10 over 4, but we can reduce this fraction, so we have to. This would be the final answer. And you can leave it as an improper fraction. And the last one, again, we distribute. I was going to say, that is why I am here. No. Yeah, at the, we'll see. All right, let's distribute. We get 12w minus 4 equals 4w plus 4. Again, color coding things. I definitely move my w's to the left.
No, we don't. We don't have school next Friday or Monday, so we have a 4-day weekend.
Why is that?
Because one of them's like ED day or something.
And one's a holiday.
Yeah, and
Yeah.
one's a holiday. Not PD. Well, you know what I mean. It's an in-service. Yeah, it is. It literally says in the calendar.
And there we go.